Okay, looking at number 13, this is kind of a strange one because your choices, you're being asked which of the statements is correct. And A and B, you're being asked if H2SO3 is the reducing agent because it undergoes reduction, undergoes reaction, or oxidation. And usually you just talk about one species. But you can eliminate A because the reducing agent doesn't undergo reduction, it undergoes oxidation. And you can reduce C because the oxidizing agent doesn't undergo oxidation. So it's either B or D. One of those is the reducing agent because it undergoes oxidation. So SN4 plus is pretty easy to look at and see that it becomes SN2 plus. So that means 2 electrons were gained over here. So this is reduction. And just to be sure, if we look at H2SO3, I've got a -2 on here and a +1. So I got a total of -6 or a -4 charge to the +1. So this must be a +3 here. And on the other side, the hydrogen's still going to be a +1 in either situation. The oxygen's still going to be a -2. So it's really a question of in HSO4, what happened to the sulfur there? Hydrogen's still a +1, still a -2, -8, +1 is -7, but there's supposed to be a minus charge. So this is up to +6. So yeah, this definitely was oxidized. So B would be the correct choice here. Okay, number 14 has a little bit of everything from the chapter in it, so this is a good final question. It says for A1, determine the oxidation numbers for Fe and Mn in the reactants and in the products. Well, Fe is pretty easy because they give you the oxidation number of 2 plus on the left and 3 plus on the right. Mn's a little tougher to come up with. On the left, you've got MnO4 with a -1 charge. Well, the oxygen is going to contribute -8, so that means Mn must be a +7 on the left. And over on the right, they let you know it's Mn2 plus. And then they asked in part B, based on your answer, deduce which substance is oxidized. That would be the Fe that's being oxidized. And then the compounds CH3OH and CH2O contain carbon atoms in different oxidation states. So here I've got a -2 on the oxygen. I've got a total of +4 on the hydrogen. So that means the carbon's a -2 as methanol. But CH2O, I've got a +2 and a -2. So now my carbon has actually gone to 0 there. And then you're asked what chemical change is needed to make that. Well, oxidation would be fine to call it that. The other thing, the other possibility they listed is if you notice H2 has been removed. So when H2 is removed, that's called dehydrogenation. Hydrogenation is when you add hydrogen to something like when you hear about partially hydrogenated oils, which actually aren't a good thing, but dehydrogenation is the opposite. So then let me clear the screen here and we'll take a look at part B. So looking at part B, you've got a reactivity series there with the most reactive metals at the top, so magnesium being the most reactive. If a piece of copper metal were placed in silver nitrate and zinc nitrate, so they want to know which solution would undergo reaction. So copper would have to be more reactive than silver, and copper would have to be more reactive than zinc for this to happen. But if you look at it, copper is not more reactive than zinc, so only the silver nitrate solution would undergo a reaction. So that would be my correct answer to part 1. Part 2, what type of chemical change would take place in the copper wire? Well, the copper wire is going to go from being copper to being copper ion. That means it's lost electrons, so oxidation is the change taking place, and that would be the half reaction for it as well. And then 3 says, state given a reason what visible change would take place in the solutions. And again, what IB expects you to realize is AgNO3. Okay, I'm getting a little tired of this board, but let me just erase this. So as far as state given a reason what visible change would take place, is you should realize that AgNO3 is a clear solution, but as Cu becomes Cu2 plus, your copper metal would be less. And the other big change you would see is that the solution would become blue as the copper ions become part of it. Then C, solid sodium chloride does not conduct electricity, but molten sodium chloride does. Explain this difference and outline what happens in an electrolytic cell during electrolysis. So I'm going to pause and scroll this up so I have some room to work on part C here. Okay, I'll try and walk you through my diagram here. It'll look better when I was drawing it. But when we have a electrolytic cell, we have the 2 carbon anodes. So this is carbon and this is carbon. I'm sorry, the 2 carbon electrodes. One is the anode, one is the cathode. The anode is the positive end, so it's hooked up to the positive end of the battery, whereas the cathode is hooked up to the negative end of the battery. So electrons are flowing to the cathode, and since electrons are flowing there, that's going to attract the positive sodium ions. And when that happens, the positive sodium ions are going to pick up an electron and be reduced to sodium metal. And then at the anode, that's where oxidation always takes place. So since that's the positive charge, chlorine ions are going to flow to that. They're going to form chlorine gas, which means it's going to take 2 chlorine for that to happen. And that's where oxidation is going to take place. And I guess I skipped the beginning here, why sodium chloride does not conduct electricity, but molten sodium chloride does. Solid sodium chloride, remember, is an ionic crystal. So it's got that crystal lattice and it's alternating positive and negative ions and held very rigidly. But when it's molten, as you can see by my diagram, the sodium is free to flow to the cathode, the chlorine is free to flow to the anode, and it's a good conductor of electricity, which is exactly how electrolysis works. So the products formed are going to be sodium metal and chlorine gas. And then what practical use is made of this process? It's for both the manufacture of sodium and chlorine. So sodium metal is used in various manufacturing as a metal, in various manufacturing items. Actually, not as a metal, it's not, because sodium as a metal is highly reactive. Chlorine gas is certainly used a lot in chlorinating pools and treating water. So I guess chlorine would probably be the more useful one. Sodium is mostly fun for demonstrations because it's so explosive in water. And that concludes the topic 9 problems.